Hello, my name is Kyle Fidakis. This is my Lab3 for microprocessors, where we have to do the equation of the summation of 2 times a factorial of I, and I is going to be 5. And then we input that, which would be considered x, into an equation 4x plus 27 divided by 2. Here, the xcalc gives me the absolute value of this number up here, which is on the lab sheet. It's 5. It checks if it's a positive number. Then we go ahead and go down to the summation, which moves the values into a different register, so we can use them in different ways. Then we call the factorial, which at the very first instance of this, we're going to be using 5, and it's going to bring us down to the factorial over here. We're going to push that value into a stack. We're going to clear R6. We're going to test R5. We're testing if it's a 0 or a negative number, and if it passes those tests, we move on to moving it to the R6, which I believe R6 is going to hold the actual factorial number. I forget, but we'll look at it really soon. Then we're going to decrement 5 into 4, and so this is going to be, I think, the multiplicand. R6 is going to be the multiplicand, and R5 is going to be the multiplier. And then this is where, if it is a 0, if R5 ends up being 0, we're going to jump to the end of the factorial function. But if it's not, we're going to call multiply. And we're going to do a bunch of things. We're going to push a couple of registers. We're going to move 8 into a register 8, and it's going to be the 8-bit counter, because that's what we're doing. We're not dealing with 4 bits or 16 bits. We're just dealing with 8 right here. And these 2 lines right here, they clear up some space that was provided into the skeleton. And I looked into them. Yeah, it's whatever with those guys. But then after we go through this part, we're going to go to kind of a loop down here. We're going to rotate to the right with carry, which means that we kind of cut it. I think we cut it in half. I think it's dividing. Let me check real quick. Yeah, rotate right with carry is a dividing by 2. If there's no carry, we're gonna go to twice, and twice kind of takes care of this part of the function that we're dealing with. And this whole multi thing was provided in the skeleton that we had for our class. And we're going to do a couple of things depending on what we have. If there's a carry or not, we're going to add. We're going to double the number basically. We could also rotate to the left, which is the same thing, but just so we can handle the bits and it's more simplistic, we add R6 upon itself. And depending on if there's a carry or not, we'll do add more or twice. But then after either of those, we're going to decrement RA, which is the bit counter. And if the next bit is not a 0, we're going to go back up to here and redo the things. And once it finally is a 0, or once it's, if it's not a 0, we're going to jump up here, and if it is a 0, we're going to move, if RA is a 0, we're going to move R7 into R6, and R7 was holding like this portion of the factorial. Then we're going to pop back R8, R7, and R5, and then we're going to return back to here. We're going to do a loop. We're going to check if going to decrement R5, so this time around it'll be 3. So we already did 5 times 4, now we're going to do 5 times 4 times 3. 5 times 4 was 20, and then we're going to do 20 times 3, so it should be 60. And we'll go down there, and I'll do this over and over again, and we'll see it in the registers. And finally, after we finish this whole summation thing, we're going to check if it's a 0. If it's 0, we're going to add, I think, a 1 to there. If it's a 0, we're going to add a 1. If it's not a 0, we're going to keep going, I believe. And then we're going to put into the whole summation number into an accumulator, and we're going to use that number in our f calculation, which is 4x plus 27 divided by 2, and x is this instance is the summation that we were doing. And here we're doubling it, then we're doubling it again, so we're quadrupling it, or multiplying it by 4. Then we're adding the constant number 27, and then we are dividing it by 2. The way we do that is we shift it to the right with carry. And then at that point we should have in R7 the number we were looking for, which is 629, I believe. Technically it's 629.5, but we can't do half bits, so it just rounds to the floor. So we're going to go ahead and run through this, save it. It'll just take a minute. Alright, cool. Start the program, go down to lab 0, or lab 3, and we're going to be dealing with the n bit all the way down to about here. So we're going to move the constant 5 to R4, and you see me, these are kind of, I put them in decimal form just so it's easier for me to see, but I can turn them to hexadecimal form too. Then we're going to clear a bunch of the registers, so they're ready to use. We're going to move R4 to R5, so we're making a copy of it, and we're going to use R5 for something else. And then we're going to call it absolute. We're testing R5. If it's negative, we're going to jump to the 2's complement, and we're going to invert it. But since it's already a positive, then we don't have to do anything, so we hit the return statement. We're going to go back to the next line that was going to be called after absol, and that's the summation line, so we're going to move R5 to R6. You can see that having, we're going to call factorial. We're going to push R5 into a stack. So nothing happens here, but in the background, a stack R5 has been pushed to the bottom of it. Then we're going to test, we're going to clear R6, and we're going to test R5, and if we're going to do a couple tests, 0 and negative, it should pass both of those, so we're not jumping anywhere. And at that point, we know we have a number we can work with. So we put it back into 6, we decrement 5, and then we're going to go to, since it's not a 0, we're not going to follow this line, we're going to go ahead and go to the multiply line, and that's going to bring us to our other subroutine. We're going to push R5, R6, R5, R7, R8, and we're going to put the constant A into R8, which is the bit counter. We're going to clear R7 just to make sure. We're going to free up some space, and here we're going to have a big number pop up, and that's moving the decimal. Let's look at it. Oops, sorry. Let's put it into binary. So we had a 1, 1 here, and we moved everything to the right, so we moved that 1 over here. And that's how we had the 5, and now it's this number. That's not something too much to worry about right now, but we'll keep it as that, so we can see what's going on with it, so we can see it shifting to the right. We're gonna jump not carry to twice. Carry is 0, so we're gonna jump to twice, and twice is gonna add R6 onto R6, so we should get a 10 at R6. And at the end of this one, we should get 20, so we'll see what happens. We're going to decrement R8, which means we already dealt with one of the bits. If it's if jump not 0, next bit. If R8 is not a 0, we're going to jump back up to next bit. And here we'll see that everything shifts to the right a bit. And then with the carry part, we're always going to carry a 1 into there. So it's going to continually get bigger and bigger, I believe. We're going to go ahead and do the same thing. Go twice, decrement it, next bit. You see the bits moving. We do have a carry this time, so we're going to go to add. And we're going to add R6 into R7. And R7 is what we're dealing with. So that's kind of what we're, in a sense, going to return. So we want to keep an eye on R7 because that's the actual value that we're returning. Then we're going to decrement, Go through this a couple more times. We're going to go through 5 more times, I believe. And we see that the bits are in R5 are moving up twice. We've doubled this one now, but that's not the value that we're going to have. This should be the final value of 5 times 4. And so you'll see it won't change after a while. And we'll wait till we get all the way to R is to 0, and we'll see what happens. Alright, so once we decrement it to 0, we're gonna, since it is a 0, we're gonna move to line 117. Move R7 into R6. We're gonna pop R8. We're gonna pop R7. We're gonna pop R5. And those were the first values that we had. Then we're gonna get out of here. We're gonna go back into our factorial. We're gonna jump back to this loop. And we're going to decrement R5. So that stands for 3. And we can look at it in decimal form. We have 3 right there. Put it back into binary form so we can see the bits moving again. Then the same thing's going to happen at the end in R7. We should have 60 because that'll be 20 times 3. So we should have 60 here. And then, yes, so 60 there. I'm going to jump through it again. So we went through that loop again. And I'm going to keep going. So at the end of this one, we should have 5 times 4 times 3 times 2 times 1, which is 120. And that's after the 2. This is after we multiply it by 1, so nothing happens. And this is where our loop kind of comes into play. So we're going to decrement R5, so R5 should be 0. And if it is a 0, we're going to jump to the end of this factorial. So we finished the first factorial of it. We're going to pop out R5. So it should turn back to, what's that? That's 1 plus, that's 5, so it should pop out back to 5, yeah? Because that's what we put in the stack from the very beginning. We haven't touched this after we were into our loop. And then we're going to go ahead and exit. And exit, we're going to go back into the summation part. So we're still in the summation. We're going to double it. It said I wrote quadruple here. I meant to double it because that's what we're doing in our summation. We're doing 2 times the factorial of 5. So we've already done 5. Then we're going to have to go down to the factorial of 4, the factorial of 3, the factorial of 1, the factorial of 0. So, and then each of those factorials we're going to have to double. So we doubled it there. We're going to add it to the accumulator down here. And we're going to go through some tests. We're going to test R5. And R5 right now is 5. If it is a 0, we're going to go to accumulate. If it's 0 before decrementing it, we're going to go to accumulate. And if it's not a 0, then we're going to go ahead and decrement it. And here it's making sure it's not a 0. So it's going to pop up back to the summation. Oh, I'm sorry. Here we're checking for the 0, so it's going to pop up to the summation. We're going to keep going down to this one, and we're testing it here. It's going to jump back to summation of R5 is not 0. So this one failed right here on line 46 because R5 was not a 0. So this one, this is true because it's saying it's not a 0, so it's going to pop up back to here. And then we're going to go ahead through this again. And I believe our answer should be 4 times 3 times 2 times 1. 4 times 3. Should have 24 added on to 240. So we should have 284. So we had 12 there. And this is just going through the multiplying thing again. So we're through the loop. decrementing that. It is a 0, so we're going to end. Multiplying it. Oh, that's right. It's going to be 288. And we're going to run through the same test again. And then this is for the third, for 3 factorial. Should be 6. And then we're going to go ahead and add it onto there because we multiplied it by 2. Put it at 3. So now our binary number is 3. We're going to check a couple things, then we're going to decrement it. It's not a 0, so this one should pass. Go ahead and do this again. Got a 4 added into there. Decrement it again. Going to be 1. I'm going to pass this test. And we'll go through the process here. So 306. And each time we get shorter because there's less numbers to work with. We're going to test our 5. It's not a 0, so we're going to decrement it. This one should pass because it is a 0 now, so we're going to pop up back to summation, and I'm going to call facto. We're going to do all these things. This test should pass right here on line 80. So jump down to 0. We're going to add a 1 into R6, and we're going to end the factorial because the factorial 0 is considered 1. We're going to double it. We're going to add it on 308. We're going to check if it's a 0 now, and if it is, if R5 is a 0, then we're going to go to accumulate. So we're going to skip the summation part, and we're going to accumulate. We're going to move R8, which is holding this whole number, into R5, so we can work with it. And we're going to move R5 into R7. Kind of arbitrary, but it helps. Then we're going to double it, because now we're going to do the 4x plus 27 divided by 2. So we're going to double this 308 right here, and then we're going to double it again, so that's 2 times x times 2, which is the same thing as 4 times x. Then we're going to go ahead and add the constant, 27, and then we are going to divide it by 2, and the way we divide it by 2 is if we shift all the bits to the right with carry. And the actual number is 629.5, but it always rounds down, so the number we're given is 629. At that point, the function is done, and that's what we got there. Thank you.